0-day brief.
You know, when you install a safety framework for your systems, there's this baseline psychological assumption that you just make. Like you trust it implicitly.
Right.
Because it is literally the piece of software designed to catch errors.
Yeah.
To block the threats.
Yeah, it's your absolute final line of defense.
Right.
You're bringing it into your environment specifically to mitigate risk rather than introduce a new attack vector. I mean, the psychological blind spot is very real. We just rarely audit the security guard.
So picture this. Imagine you were driving on a really treacherous mountain highway, and you feel totally secure because there are these heavy steel guardrails between you and a massive sheer cliff.
Makes sense.
But what you don't know is that overnight, somebody came along and replaced those solid steel beams with cardboard. Cardboard that's been, carefully painted to look exactly like galvanized steel.
Wow.
Yeah. And you have absolutely no idea anything is wrong until you inevitably lean on them.
Mm-hmm.
And, well, by the time you realize they are fake, you are already falling.
It's a terrifying thought. And the safety framework itself becomes the lethal trap. It's actually a chillingly accurate metaphor for what we're looking at today with the Guardrails AI supply chain attack.
Yeah.
We are seeing a complete inversion of trust here.
And that inversion of trust is really our focus for this deep dive. Our mission today is to unpack CVE-2026-45758.
A huge one.
Massive. It was a massive supply chain attack targeting the Guardrails AI package, specifically version 0.0.1. And we're going to explore how the attackers entirely bypass the AI models to directly target the developers building those models.
Which completely changes the game.
Exactly. And we'll look at what this paradigm shift means for your own security posture. Okay, let's unpack this. How does a tool, one trusted by hundreds of thousands of developers to validate AI outputs, end up fetching and executing a remote payload without a single warning or function call?
Well, the entry point really tells the whole story here. For an attack on an advanced AI infrastructure tool, you might expect, some incredibly sophisticated algorithmic manipulation.
Right, like prompt injection or something.
Exactly. But there was no prompt injection here at all. There was zero training data poisoning. The attackers, their group identified as TeamPCP, they completely ignored the AI models.
I mean, I'm assuming that means they must have found like a 0-day vulnerability in the servers hosting the models or something, some highly technical server-side exploit?
Actually, no. They bypassed the servers entirely, at least at first.
Wait, really?
Yeah. The entire exploit chain started with a single devastating credential theft. Just one stolen GitHub Personal Access Token, or a PA, belonging to a Guardrails employee.
Just one token. Wow. Mm-hmm. A PA is essentially, it's a developer's digital ID badge for GitHub, giving them command line access to repositories.
Right.
And Guardrails hasn't said exactly how the token was stolen. I mean, maybe a phishing email, maybe it was accidentally hard-coded into a public configuration file. But the initial theft isn't what makes this so terrifying.
No, it's the blast radius. That token was really just the first domino. TeamPCP used that single PT to trigger GitHub Actions workflows across 30 different repositories within the Guardrails AI organization.
30?
30. They essentially told the automated CI/CD systems, which are like the assembly lines of the software, to wake up and run their routines.
Okay, so when you trigger a workflow, it spins up a temporary virtual machine, compiles code, runs tests, and then it just destroys the machine.
Exactly.
And the only things left behind are the build artifacts, things like test coverage data, compiled binaries, maybe some error logs. But wait, aren't build artifacts basically just temporary outputs, like a digital recycling bin? Why are the keys to the kingdom, like actual deployment credentials, just sitting in the recycling bin?
What's fascinating here is you've intuitively hit on the first major structural failure of this entire event. I mean, developers view build artifacts exactly as you described. They're fundamentally designed to hold temporary build outputs.
Yeah, exactly.
Nobody treats them like a secrets vault.
But somehow secrets ended up in there anyway.
Yeah, and this happens due to incredibly common pipeline misconfigurations. If a workflow is passing deployment credentials, say, an API key to publish a new software release, into an environment, and the logging generation isn't strictly sanitized.
Oh, it just prints it out.
Yes, those secrets can print right out into the plain text logs, and here is the fatal flaw. Anyone with read access to that artifact now has read access to the secret.
So they didn't even hack a secure key management system. They just tricked the automated build system into printing the keys out for them in plain text.
Exactly.
Yeah.
TeamPCP extracted PyPI deploy tokens directly from those artifact logs. The entire cascade of this attack relied on the broken assumption that build outputs are just temporary trash and therefore, safe to leave unaudited.
And PyPI, for those listening, is the Python package index. It is basically the central nervous system for almost all Python software.
Right.
If you type pip install anything, you are pulling from PyPI. So having a deploy token for a popular package on PyPI it's like having the master key to the city's water supply.
Spot on. And with those tokens in hand, TeamPCP was ready to orchestrate something much, much larger than a hit on a single AI company.
Here's where it gets really interesting, because this wasn't an isolated incident. It's like a coordinated heist where the exact same crew robs two different banks on the exact same day using completely different blueprints.
Yeah.
Like they're walking straight through the front door at PyPI while simultaneously tunneling through the vault floor at NPM.
It really was. We were talking about May 11, 2026. On this specific day, TeamPCP executed what I'd call a dual registry masterclass. You mentioned NPM, which is the JavaScript equivalent to PyPI.
Right.
On the NPM side, they deployed the Shai-Hulud attack, which is also known as the TAN-stack worm.
Okay.
That attack was highly complex. They managed to extract OIDC tokens directly from GitHub Actions runner memory.
Now, I hear OIDC tokens mentioned all the time in modern security architectures, OpenID Connect. But what are they actually pulling out of memory in this case?
So, in modern development, you really don't want to store a permanent hard-coded password. Instead, you use OIDC to essentially ask a cloud provider for a temporary VIP pass.
Got it.
A system says, hey, I am a GitHub action running a verified workflow. Please give me a token to publish to NPM and make it valid for just 5 minutes. It's incredibly secure, in theory.
Right, in theory.
Yeah.
Unless the attacker manages to just dump the memory of the machine during those exact 5 minutes.
Which is exactly what TeamPCP did with Shai-Hulud. They scraped the live memory, grabbed those temporary VIP passes, and used them to poison 84 different versions across 42 packages on NPM.
That is insane. So that's the tunneling through the vault strategy. Highly technical memory scraping. But simultaneously, over on PyPI, they use those deploy tokens they grabbed from the Guardrails artifacts to just casually stroll through the front door.
Yeah, they literally just walked in. They published the malicious version 0.10.1 of Guardrails AI, and it was cryptographically signed, authenticated via the valid token, and entirely indistinguishable from a legitimate release. They also used this exact same vector to poison the Mistral AI Python SDK at version 2.4.6. We're talking over 100 packages compromised across 2 major registries in a single 24-hour window.
Let's talk about the payload itself for a second, because a developer sits down, sees there's a minor version update, and types pip install Guardrails AI.
Sure.
I've always assumed that when you import a library in Python, you're just pulling the text of the code into your project so you can reference it later. Like, I don't know, opening a reference book. It shouldn't be able to just execute actions on my computer without me explicitly telling it to.
And that is a very, very common misconception, and it is exactly what attackers exploit. In Python, when you import a package, it actively executes the code inside the package's initialization file.
Oh.
Yeah, the underscore.py file. It runs that to set up the environment.
So literally the moment the import statement runs, the payload executes.
It executes silently. TeamPCP injected their malicious script directly into that init file. It reaches out over the internet, fetches a secondary remote Python artifact, and just runs it on the host machine.
That's terrifying.
Yeah, there is no warning. There is no prompt asking for permission. Just importing the safety framework triggers the threat.
So what is that secondary artifact actually doing once it lands on the developer's laptop?
Based on documentation from Step Security covering this broader campaign, the payload is absolutely voracious. It immediately begins harvesting credentials.
Like what kind of credentials?
We are talking about targeting over 100 distinct file paths on the local machine. It hunts for cloud provider keys, SSH private keys, GitHub tokens, local API secrets, basically everything that gives that developer access to their company's infrastructure.
But I would think a corporate firewall would catch this. Like usually, if a random script tries to send a massive zip file of stolen passwords to some unknown IP address in another country, the network security tools step in and block the command and control server.
And the attackers anticipated standard network defenses. The payload doesn't send the data to a traditional static command and control server. It actually exfiltrates the stolen data using the session protocol.
Wait, the decentralized messenger?
Yes, the session protocol uses an onion routing network, so it wraps the data in layers of encryption and bounces it through a decentralized peer-to-peer network of nodes.
Oh, wow.
Because it's decentralized, there is no single attacker-controlled IP address for a firewall to block. To a network monitor, it just looks like standard encrypted UDP traffic blending in with the background noise.
That is incredibly stealthy. And the sources mentioned they didn't just stop at pillaging the developer's local machine, right?
Yeah.
Once they had those credentials, they tried to move laterally deeper into the network.
Exactly. Once they established footholds via the compromised developer machines, TeamPCP attempted to move laterally into Guardrails Ray cluster.
And for you listening, a Ray cluster is essentially the heavy-duty infrastructure used for scaling distributed computing. In this specific case, it runs the remote validator inferencing for the AI models. It's basically the engine room of the AI.
Right. The attackers wanted to move from the developer tooling directly into the infrastructure running the AI itself. That specific lateral movement attempt failed, and their attempts to publish to additional registries also failed. But the sequence of events exposes two more massive systemic issues in the industry.
Okay, well, we covered the first one, which was build artifacts acting as accidental secret storage. What's the second?
Structural failure number 2 is that package registries lack secondary verification. Whether it's the NPM attack extracting temporary OIDC tokens or the PyPI attack using a stolen employee PT, the result is the same. When a package is published, PyPI does not ask for a second factor like an authenticator app code.
And neither does NPM.
Exactly. The registry blindly trusts the token. If the token is valid, the door opens, and you can push malware to millions of developers.
There's no human review step, no anomaly detection saying, hey, this new version is radically different from the last 10 versions and inexplicably fetches a remote payload.
Exactly. And structural failure number 3 is perhaps the most profound for the future of our industry. The AI toolchain is now a mapped attack surface. You do not have to hack the AI. You hack the tools that build the AI.
TeamPCP didn't just spray and pray malware into random obscure packages hoping someone would accidentally mistype a name. They hit Guardrails AI, a framework with nearly 7,000 GitHub stars and roughly 750,000 downloads a month.
Right.
And they hit the Mistral AI SDK. This is the supply chain attack completely reimagined for the AI era. You compromise the developers first, you use their access to get to the infrastructure second, and then you compromise the downstream applications third.
And that sequence all hinges on a race against time, the speed of execution versus the speed of detection.
Because this payload executes silently the second you import the library, right?
Yep.
So the only thing standing between a clean system and a total enterprise compromise is how fast the community realizes the package is poisoned.
The timeline is incredibly tight. On May 11th, the malicious version 0.10.1 hit PyPI at roughly 6 p.m. Pacific time. Detection took about 2 hours.
I mean, in the grand scheme of software vulnerabilities, where a bug in a router can hide for like 5 years, 2 hours, is unbelievably fast.
Oh, absolutely.
But if I'm a developer and my automated systems pull in updates every hour, 2 hours is an eternity. A download takes 5 seconds. Execution takes a millisecond. If this payload is so stealthy and using decentralized routing to hide its network traffic, how did anyone even notice it in 2 hours?
Socket's AI scanner caught it. And notably, this was the exact same scanner that caught the tan stack worm on NPM earlier that same day.
Wow.
Yeah. Traditional scanners look for known bad signatures, kind of like a fingerprint. If they haven't seen the malware before, they just miss it entirely. But behavioral AI scanners analyze the code's intent.
Ah, I see.
The scanner basically asked, why is this mundane AI math validation library suddenly importing operating system modules, reading SSH key file paths, and opening decentralized network sockets?
So basically, we needed an AI drone flying overhead to tell us the guardrails on the highway were made of cardboard.
Yeah.
Because looking at them from the driver's seat, everything appeared totally normal.
That's exactly right. Once flagged, PyPI immediately quarantined the package. But the fallout for anyone caught in that 2-hour window is severe.
Yeah.
Guardrails' internal response sets the baseline for how seriously this needs to be taken. Once they confirmed the breach, they executed a really draconian remediation. They didn't just delete the bad package, they rotated every single token across their entire GitHub organization. They factory reset the compromised employees' devices.
They even took their Ray cluster and validator hub offline completely to inspect it.
They forced the rotation of all Snow Globe and Guardrails Hub API keys too. Moving forward, they have fundamentally restructured their GitHub posture.
Making it stricter, I imagine.
Much stricter. Classic personal access tokens are now restricted from organization access. They require fine-grained tokens with strict approvals and expirations. Plus, every commit on every branch must carry a verified cryptographic signature.
That is a massive operational overhaul. But that's what the company did.
Yeah.
Let's put ourselves in the shoes of the listener for a second.
Mm.
So what does this all mean for you? If you upgraded during that 2-hour window, you can't just replace the cardboard guardrails. You have to pull over and inspect every single car that drove past them. Imagine you're working late on a Tuesday. You type pip install Guardrails AI, and you happen to hit that 2-hour window.
It's a bad night.
The level of panic you would feel reading the security advisory the next morning. What is the actual action plan for that developer?
For users, the math is simple, but the reality is harsh. If you installed version 0.1.1, you must assume total compromise of that machine.
So no, maybe just look at one project folder. You have to burn it all down.
Have to burn it down. The payload executed on import, and its net was incredibly wide. You have to rotate everything on that host.
Everything.
Everything. That means your personal GitHub pages, your corporate cloud provider keys, your package registry tokens. You need to rotate the API keys for every single service you are logged into from that machine.
And I assume you'd also need to audit your GitHub account, right? Checking for unauthorized workflows, looking for new repositories you didn't create, or commits you didn't make.
Oh, 100%. And honestly, given that the payload installed persistence hooks into developer tools like VS Code and Claude Code, you should strongly consider a full machine reimage.
Just wipe the whole laptop.
Yes. You simply cannot trust the operating system on that laptop anymore. Even if you delete the malicious package, the attackers still have a backdoor into your development environment.
Right.
Once you've scrubbed your environment or gotten a new machine, then you can safely pin your Guardrails version to 0.10.0 or upgrade to 0.10.2.
Because the malicious 0.10.1 is quarantined on PyPI, so pip will refuse to install it anyway. And if you use Snow Globe or Guardrails Hub, your API keys were proactively invalidated by the company, so you'll need to rotate those before you experience a service interruption.
Exactly.
It is an absolute nightmare of a checklist, but it's really the only way to be sure you aren't leaving a door open for TeamPCP.
If we connect this to the bigger picture, it took a single automated AI scanner to catch multiple coordinated campaigns across different ecosystems simultaneously.
Yeah.
TeamPCP hit Python and JavaScript registries using completely different attack vectors, and one behavioral scanner flagged both within hours. Human reviews simply cannot scale to meet this level of coordinated, automated supply chain poisoning.
So the technology they are attacking is cutting-edge AI infrastructure, but the doors they are walking through have been unlocked for decades. We're talking leaked credentials sitting in temporary build artifacts, package registries that blindly trust authentication tokens without requiring two-factor authentication, and CI/CD pipelines built to push code as fast as possible rather than as securely as possible.
This is really the scaling phase of supply chain attacks. The threat actors have mapped the terrain, the validation frameworks, the SDKs, the inference clusters. These are the new front lines.
So we find ourselves in a strange new landscape. We are building these incredible, powerful AI systems. And to protect them, we are relying on automated AI scanners to police the very tools we use to build them.
It's a wild cycle.
It really is. Which leaves us with a lingering question to ponder as we wrap up this deep dive. If automated AI scanners are now the only defense mechanisms fast enough to catch malicious updates to our AI toolchains, are we entering an era where AI is simultaneously the ultimate target and our only viable security guard?
That is the question.
And if so, who is validating the AI scanner? Something to think about the next time you lean on those guardrails.
Thank you for listening to Zero Day Brief.